Hello, let's do checkpoint 6.37. They want us to find a stream function for the vector field f of xy equals to x times sine y, comma, cosine y. So what is a stream function? We can say that g of xy is a stream function of a vector field f, and let's put some components for f, p, comma, q. If p is equal to the derivative of g with respect to y, and q is the derivative of g with respect to x except negative. Let's write that negative sign a little bit clearer. Negative g of x. All right, and graphically that means if you have a vector field that maybe goes through like that, we would be following this point as if these vector fields were like tangent lines to a particular curve. And this curve would be like a level curve of G. So if we were to draw a level curve, you can see that these should be tangent lines. This is different from conservative vector fields where you would draw level curves, and those level curves, the vector fields would be perpendicular to the level curves. Here, the vectors in a vector field would be tangent to the level curve. All right, so this is our criteria, and we simply follow it like we did when we were finding potential functions. Okay, so let's find the stream. So we're going to assume that this is P, and we're going to assume that this is G of y. So that means we have taken the derivative of G with respect to y to get that, so we should take, in order to get G back, we should take the antiderivative of P with respect to Y. Again, this is different from finding the conservative, the potential function. So we're going to integrate x sine Y with respect to Y, and the antiderivative sign is negative cosine. So we will have negative x cosine Y. And again, we want to allow for some function. We're taking this with respect to y, so we want to allow for some function of x here. All right. Similarly, we're going to say our g is also equal to the integral of q with respect to x, but there's a negative in front of that, so let's incorporate that negative sign as well. All right, so we're going to look at the integral of a negative, and this is the q function, cosine y dx. We're integrating with respect to x. Antiderivative of cosine is, or not, no, cosine is cosine y is constant with respect to x. So the antiderivative of just a number is going to be a number times x, and we'll throw that negative sign in there. So it'd be negative x cosine y plus some function possibly of y. And we can see that we have these two functions in common, so that must be our g function. So g of xy is equal to negative x cosine y. And we can throw a constant in there if we want, a true constant, not a function of x or a function of y, but just as a plain constant. Now the idea is that if we draw level curves for this, let this equal to 0 and change the value of c, then you will have a bunch of curves that will be tangent to this, or these vector fields. The vectors in the vector fields would be tangent to those level curves. So I encourage you to draw that in CalcPlot 3D to get a visual of what's happening. But for now, this is our stream function, and I hope that helps.